We're standing here in the forest canopy at Wytham Woods, which is Oxford University's research forest just outside of Oxford. And here we're looking at how the forest functions, how climate change is affecting the forest, and improving our understanding of the carbon and nutrient cycling and the physiology of these forests, with the aim of improving models and predictions of how the biosphere will respond to 21st century climate change. And Wytham here is simply one hub of a global network of over 40 sites, predominantly in tropical forests around the world, where we are replicating exactly the methods and the research that we're doing here. And the type of things that we do here include tracking the growth and death of trees, tracking the cycling of carbon and nutrients through the growth of trees, through litter fall, through the roots and soil, and also monitoring the flow of carbon in between the canopy and the atmosphere above, to come up with a really comprehensive description of the functioning of this forest. On top of that, we are interested in seeing whether we can describe the biomass and the functioning of this forest from airborne remote sensing or satellite remote sensing. So we're trying to explore new detector technologies, looking at the spectral reflectance of the forest canopy to work out whether we can go as far as monitoring the productivity and response of forests to droughts or to other aspects of the climate. And as well as being a research site in itself, and this is a flagship site for us in Europe, this is also a training ground where many of my researchers and research students come to learn the techniques and then take them to far off places such as the slopes of the Andes, the heart of the Congo Basin, deep into the Bornean rainforest, to apply these in places that no one's described the functioning of ecosystems before. We are building a detailed description of the functioning of the biosphere and the tropical biosphere in detail. And once we couple that with our airborne observatories and our work with satellite data, our aim is to come up with a global forest monitoring system that's built on a deeply mechanistic understanding of the system. And that's the important thing, that we are really trying to understand the mechanism of what makes a forest tick, which is essential for understanding how it'll respond to 21st century change. We believe that we are able to see over the last decades of work that we started in the Amazon in particular, and now as spreading elsewhere, we are able to see the effects of global change on the functioning of forests. So across the Amazon, what my group and our colleagues have found is that forests seem to be increasing in biomass, and also the trees seem to be shortening in their lifespan, so turning over faster. And we believe this may well be a response to the higher atmospheric carbon dioxide concentrations. So for now, this effect in tropical forests may be absorbing between 10 and 15% of our fossil fuel greenhouse gas emissions, carbon dioxide emissions, so acting as a moderate brake on climate change. The concern is that at some point this brake may turn into an accelerator, and so rather than being a negative feedback, the biosphere, if it's pushed far enough, may end up being a positive feedback and an accelerator of climate change. And we're trying to understand what those thresholds are that tip those tipping points in the tropical biosphere.